Ohm's law problems for series circuits. Remember, series circuits have components arranged one after another in one continuous loop. Here's an example of a series circuit with 3 resistors lined up. I'm going to label these 1, 2, and 3. Resistor 1, 2, and 3. Now, let's go over the rules that we have for series circuits. When we look at total current, the total current flowing through the circuit is the same as the current for each resistor. So these are all equal. Okay, so the current flowing through 1 is equal to the current flowing through 2, which is equal to the current flowing through the entire circuit. So this is the same. Now, total voltage. This is a little different. Total voltage comes from the battery, so the voltage coming from the battery would equal the sum of the voltages across each of the different resistors. We call this voltage drop. So the voltage for 1, V1, plus V2, plus V3 is going to equal the total voltage coming out of that battery. Alright, next up, we call this equivalent resistance. Equivalent, I want you to think of as total resistance. Now, when we solve for the total resistance, all we do is we add up the values for each of the resistors, and that gives us the total resistance as if we were drawing this with just one resistor. What would the resistor value be? This would be what you call R equivalent, okay? So if I were to combine these 3 resistors into one resistor, what would the value be? And you get it by finding the sum of the resistances in the circuit, and that's Req.